Hi there, Steve Hart commented on my previous video, which is about the Behringer DX2000 USB. He asked, how do you achieve microphone muting? So this is muting of your speakers when your microphones go live. There's a few ways you can do this. There are many ways to skin a cat, but what I wanted to do is show you how I did it. So this is what I mean by mic muting. This is a feature that if you are using a mixer for radio is really important. What it does is it turns the speakers off when your mic goes live, but leaves your headphones able to hear the audio. So I've got, on these mixers you've got two microphone channels, and on my first stereo channel I've got one of the outputs from my computer. And here's how mic muting works. If we play some music, here's some music, I push up the fader, the microphone fader, and the speakers go off. Put it back down again, the speakers come on. Now this doesn't affect the recording output, that stays as the audio stays feeding out the recording output, and it doesn't affect the headphones either. So if I turn my headphones up and I monitor the output, you'll be able to hear that I've still got some audio there, but nothing coming out of the speakers. And that's exactly what you want. When you've got these things on, you're not going to get much audio leakage, if anything, from inside your headphones to the microphone. But of course the studio monitor speaker will be picked up by the mic. So how do you do it? Well, what you do is, I went down the route of making an external circuit, a relay-based mic muting circuit, which is this box here that I've created. You can see it's controlled by the fader, and the output from the mixer is one side, going into one side of this box, and then the other side of this box is the post mic muting circuit output. And it's arranged so that normally, when the circuit's not energized, it's just a default normally closed, and the audio is allowed to pass through transparently. But when the microphones are up, the circuits and the relays are energized, and that breaks the continuity, and it stops the main output from reaching the speakers. So what I'll do in a sec is open up the mixer and open up this box, and I will show you the circuit that I've used to achieve this. There are two parts to it. There is a part that you actually embed inside the mixer itself, and then there's an external box that you create, and this involves a little PCB that you have to put together, which has got a couple of relays in it. So we'll go over to what you do inside the mixer. Now you start off by tapping 12 volt and 0 volt from the power lines that feed the external lamp that you can plug into the mixer. There's a little socket that's very easy to tap, and that can give you your 12 volt and 0 volt. And then you take the 12 volts and you run some little wires inside the mixer to a couple of microswitches that you position alongside the microphone faders, that's fader 1 and 2, on the Behringer DX2000 USB. These switches should be normally closed, so that if nothing is pressing on them, the switch is closed and the circuit is made. And you position them so they're right next to where the fader stem is going to be when it's right at the bottom. So the idea is that when the faders are down, the switch is open, but then the moment one fader is moved up, the microswitch pings back into its normally closed position, and that allows 12 volts to appear here, which is which is a breakout cable that we're going to use to feed the power into our external circuit. So you only need one of the microphone faders up for 12 volts to appear there, but you can have both up. In other words, both need to be down, and both switches need to be depressed, and therefore need to be in their open position in order for this 12 volts not to be here. And this is the basis for how we will power our muting relay. So what we do is we then take this 12 volts, we use a little breakout cable and bring it across to an external black box, which is our relay muting box. I've deliberately used relays because I wanted to have a box where I could remove it from the circuit if I wanted to, so I could remove the muting functionality without having to get my soldering iron out. So I really wanted a separate sort of plug and play system. Now you can, if you know what you're doing, you can tap the actual mixer's chips, and there are some operational amplifiers in there that have a muting function, and you apply a certain voltage to a certain pin, but that's messy, and it also means you might damage those chips, which are far harder to replace. So this way of doing it, the only real thing you do to any of the mixer's internal electronics is snipping a wire that powers the lamp, tapping a feed off it, and then you can of course rejoin that wire if you want, and I'll show you how I've done that in a sec. So anyway, let's come over to this external muting box. Now the way this works is the sound, which is a left and a right channel, it comes in on one side of the black box, the input, and it goes out on the other side of the black box, the output. And the system is wired up such that if you do nothing, if this circuit is not active, the left channel input is connected all the way through to the left channel output. So there's a continuous path there, so sound will reach the speakers. Same thing for the right. And at the heart are these relays here, which are wired up such that when these relays are switched on, a switch is thrown that breaks this connection, and so the left channel is no longer connected to its output. That's now just floating. The right channel is no longer connected to its output. This just applies, by the way, to the center pin of the phono plug, the hot. The cold or the common is always connected no matter what, because of course you need a complete circuit for the sound to flow anyway. So the way this works is pretty straightforward. What I've done is I've picked two relays here that are 6-volt relays, and I've wired them in series. The idea for having two of them is because you have two channels. You have a left and a right channel and a stereo output. Now you can get relays that have got what they call double pole, which are two different channels in them. But I wanted to minimise what they call crosstalk, which is the amount of signal that bleeds from the left to the right and vice versa. And the best way of doing that is to physically separate these lines on the PCB, and it's so much easier to do that when you've got two separate relays. I've deliberately chosen relays that have got a decent coil resistance, and this means I don't have to mess about adding series resistors in, so that when these when these relays are energized, there's enough resistance so we're not going to end up overheating up the circuit board or burning things. And the reason you go for 6 volts is because they're in series. They will each drop the 12 volt voltage in 2 steps. If you are wiring up a double pole double throw relay, just a single one, you'll need to be a 12 volt relay. And if you're wiring these up in parallel, they should be 12 volts. But I've gone for 6 volts here because putting these coils in series essentially doubles the path resistance and reduces the current consumed by the circuit. So what happens is when the microphone fader is up, there's 12 volts out here that comes across into our black box, and that energizes these relays. The relays flick their internal switch over from there to there. This breaks the path of the left and right sound to the output, and so the sound no longer reaches the output. There's a few other little bits to note here. There is a flyback diode. You need to put this across any what we call inductive components, anything with a coil in it, because what happens when you de-energize the relays is they actually, as the magnetic field around these coils collapses, it generates its own little voltage, and that can actually damage other components. So you put a little diode pointing the wrong way from negative to positive to discharge this spurious voltage that is created, and that stops any damage to the mixer. And you need one of these for each of the relays. So that's what that's about. And then I've added in parallel to all of this just a little resistor and an LED here, so that whenever this circuit is energized, that LED is on and you can see that it's in muting mode. It's quite useful. Now you can go to town on this. You could tap off some really elaborate LED array and have a big red Mike's Live light if you want to. But I've just got a little small light so I can see when the circuit's energized. So if I fire up the mixer and I start doing things and I can't hear any sound, I look at that and I can see, oh, looks like the mic fade is slightly off 0. It's muting at the moment. So in summary, you put a microswitch by the microphone faders so that when the microphone fader is up, the circuit is completed. You take the output from these microswitches to power a relay box. The relays are in a position such that normally when they're closed and not energized, sound is able to get from input to output, and when they're fired on, the sound can't get from input to output, and then you just have little stuff to protect the circuit and an LED to tell you when it's actually muting. Net result is push your microphone fader up, the input to output side of this black box breaks the circuit, no sound goes out and reaches the speakers. Okay, so we're going to open this now. I'll show you how to open it, which I didn't show in my last video, but just before I do, I just want to show you the back of it. This is how you might wire this thing up. This is the master output, which I'm just using to feed my speakers. This is my wonderful black box, my muting circuit. And I've got this cable here. I chose to do a coiled RJ, I think it's an RJ11, but like telephone-like cable, for the 12 volt power feed and the 0 volt return. So you'd have a short phono run or a short run going from your output to your black box, and then this would go on to your speakers. Pretty straightforward there. Now, the nice thing about doing it this way is if I don't want to use the muting circuit, I can just unplug it completely and wire that directly to the output of this directly to my speakers, and boom, I've just got the mixer how it was before without any trouble. Because it's a normally closed arrangement, you know, you don't have any spurious connections, power, or anything funny going on, which is nice. Okay, so let's just open this all up now. I'll speed this up so you don't have to watch me doing it. I've actually replaced the screws in the sides with my own ones because they're actually quite a soft metal, so it's very easy to damage them when you're undoing them. So I've actually replaced mine with these little Allen key ones. So what you do is you undo both side panels on the left and the right. There are loads of these screws on here, and then you undo the back and the underside. I'll show you in a sec. So let's just get these done. So all of that gets your side panel off, and then you're able to see that view in the mixer that I showed you on my other video. That's the side panel there. We're going to do the same to the other side panel here, and we're also going to undo these screws at the front bottom of the mixer, because these are the ones that hold that continuous sheet of metal that has all the controls mounted on the front, and we're going to undo these screws across the top of the back of the mixer, because these are the ones that hold the other side of that sheet metal. So next one is the panel on the opposite side. So that gets us our second panel off, right? So that's the second side panel. Put those over there. Just before I take off open the top of it, I just want to show you my how I've managed to get this extra cable out the back. So look at the rear of the mixer here. I've got my muting box here, and this is the extra power feed that I've extracted. What I've done is I've badly Dremeled a little window in there. Unfortunately, I didn't have a small enough disc on my Dremel, so I couldn't make a nice neat hole. The usual way I do that, something like this, is I drill a little 2 or 3mm hole in each corner of the square window that I want to take out, and then I'll use a very fine, in this case it was the Dremel angle grinder, to cut between the holes, and then you can take your little rectangle of metal out. And then if we look in the inside, what I've done is I've fitted an RJ, I don't know if you can see that with the focus, I've fitted an RJ11 socket here, and I've just simply glue gunned it in place. There's not going to be that much force on this socket, so I've gone and just smothered it in glue there. I'll walk you through all the wiring internally in a sec. So the next thing we want to do if we want to undo this, let me take my box out so I don't damage it, is to undo the top plate from the back and from the front. So I'll do that now. So we have got now a mixer that we can open. You can lift the top up. You have to be careful because there's certain things that are attached, but this is how it looks inside. I'll walk you through the anatomy of it. This is the power module, and if this were plugged in, this would have mains power in this shielded segment. And what it does is it gives off various low voltage power to various parts of the mixer. I think it's able to give out 14 volts, 12 volts and 5 volts. What you can do is you can just disconnect this, and this will allow you, there's little white terminals, and then just get those on the screen. You can see a little white block here, a little white block here. These you can just lift out and they will disconnect your power. Alternatively, you can disconnect up here. I actually find this is an easier connector to release, so we'll just release that for the moment. So the anatomy of the mixer, you've got your power, your mains power coming in here, comes in via here, and this is a transformer, and this gives out I think 14 volts, 12 volts and 5 volts. This little connector here feeds this board, which is your control board for your output. That's for the output faders. There is your mixing board here, which supports, which gives you all of the EQ functionality, the FX sending, the PFL, and supports the faders. So these are your faders here, and then you've got your input and output boards. You've got your output amplifiers on here, and you've got your inputs here, and that basically supports all the connectors on the back of the mixer. Now, this is where we are able to tap the power from. There's a little power supply coming off the power supply unit that goes up and eventually supplies the lamp here. Now, interestingly, this is 12 volts. There is a control on the front that allows you to adjust the voltage of it, but when that's up, that's 12 volts. This is where we're able to tap 12 volt power from. When you first open your mixer, you'll find that you'll see this little small red and black pair of leads that goes between the power supply straight into, you can see it, the little socket here, which corresponds to this BNC socket here, which is where your lamp goes to. That's what we're tapping. And what I've done is I've actually gone and put, because I like to be neat, I've gone and put a little bit of PCB in here, but you could just use terminal blocks. Just make sure there's no exposed components, no exposed metal that might short on the case. So what I've essentially done is I've snipped that cable with the 12 volt positive and 0 volts in two, branched off my 12 and 0 volts, and then I fed that out the back of the mixer I fed that to my control board, which will be where the faders connect to and do all their switching goodness. So the next important part is the micro switches on your faders. Now the way I've done this is, if you can see here, and I'll take a close-up in a second, I've mounted a little tiny micro switch just alongside the fader. So this is how you fit the micro switches such that the faders cause them to mute. I've got here the little lever of the micro switch, and that is pointing just across the top of the fader. You can probably just see the stem, the bar of the fader, moving up and down. And the idea is when you get to the bottom of the fader, when the microphone is going to be in the off position, it presses against that lever and closes the microswitch. So can you see how that stem is pressing that microswitch down? So what you've done essentially is you've mounted a microswitch just next door to the fader, and you've made it so its lever is pointing just ever so slightly across the fader like that. So when the fader is down, that lever is pressed in and the switch is closed, or the switch is depressed. And remember, we're wiring this up in normally closed orientation, so that when your switch is activated, you open it. So when I'm down like this and my switch is pressed, I'm actually breaking the circuit. The moment I move one of the microphone faders off and that switch pops like that, it is then closed again and the circuit is completed. So the switches, the micro switches on fader 1 and fader 2 are connected to the 12 volt source, and their outputs are connected back together via this long cable that I've put in. I deliberately made it long so the lid was easy to open, and then that goes over to this little mini PCB that I've just put together, which connects to the 12 volts that I have tapped off from the light here. If you just follow the circuit, you tap your 12 and 0 volts off the light, you bring 12 volts into one side of the switch, and you take the output from the other side of the switch, bring them together, that'll do it for you. And it's this that you pass out to your external box. So that goes out to the little connector that I lashed onto the rear panel here and then glued in place. And then the other bit of this connector just goes straight to the 0 volt line that would have otherwise supplied the lamp. And that's actually all you need to do in the mixer. So you simply tap 12 volts, you fit 2 micro switches next to your microphone faders, you wire them up as I've described. You need these ones normally closed so that when that fader's down, it's pressing the switch, the circuit is broken. And it's the output side of this switch, which would be carrying 12 volts when the switch is in its normally closed position, is what goes out the back of the mixer and onto our muting circuit. So that's this bit here. So now we come on to the actual muting circuit itself. This is just a standard ABS box that I bought on AliExpress online. I've fitted, these were these pre-existing modules you could get with 2 phono plugs on, so I just bought those so I didn't have to go drilling loads of precisely positioned holes and muck about with tabs, so I was being a bit lazy there. You could do a neater job if you wanted to. And what I've done is I've Dremeled a hole in the side so I could fit my RJ connector in. That's what's going to be bringing the 12 volts into this circuit. So you've got a pair of phonos on one side, a pair of phonos on the other side. It doesn't actually matter which way round you connect your phonos. Either side can be input and output. It's not a directional circuit anyway. And then the other connection I've got this multi connection here, which basically just brings 12 volts in and takes 0 volts out. As we've described, 12 volts coming from the output side of those micro switches. So let's just open it and you can see what it looks like. Remember, this is a relay based circuit, so in here I've got 2 relays and I've got a little indicator LED as well. So simple PCB with my 2 relays on. I'm gonna regret taking this out. It's quite tightly packed in there. And you can see you've got your relays there. There are your 2, if you can see that. You've got your 2 blue relays here, and then I've got the various wiring on the board. I've actually deliberately used shielded cable whenever I've been tapping the audio signal, and I've been just careful to minimise the amount of unshielded runs that audio signal has on the PCB, so that you don't get problems with crosstalk. Now the good thing is that relays are actually quite low noise at audio frequencies. So even though there is a little micro spark when they throw, when relays move, you don't really get any problems at audio frequencies, so you don't generally need to worry about that. That's not true if you are switching RF circuits, so you can't use this for much higher frequencies. But pretty simple box. I'm sure you guys can do a neater job. And as I say, it's this bit, 2 relays, controlled the moment you energize the circuit, LED goes on, relays flip, disconnect input from the output, the output audio goes silent. That's it, and that 12 volts arrives through the little side panel that I've lashed through my RJ connector, which comes from the mixer. And that's it. That's how you do mic muting.